So now we're going to start having a look at discrete random variables. Okay, discrete random variables means that they can only take on set values. Another example of a discrete distribution would be the binomial distribution. It can only take on set values, not decimal values. To find the mean for a discrete random variable or a discrete probability distribution, we are going to have to do the outcome times the probability of that outcome happening, and we're going to have to add all of those together, which is what this summation sign here means. This symbol here that looks a bit like an E, so it means that we're adding together the outcomes times the probability of that outcome. We are also going to have a look at finding the standard deviation. However, just like with the binomial distribution, we don't have a formula for finding the standard deviation, but we do have a formula for finding the variance. And then for the standard deviation, we are going to square root this. Okay, so we'll notice that here we have in our equation for finding the variance, we can see that we have the mean squared, and we have this e of x squared. Now to find the e of x squared when it's like this is e of x all squared, this is e of x squared. We're going to have to do the sum of x squared times the probability of x equaling x. So that means that this time we're adding together, because we still have this summation sign, so we're adding together the outcomes squared times the probability of those outcomes happening. So this time we have to square the outcomes before we times it by the probability and add them together. The mode is the one that is most likely to happen, and this is easily found because it's the highest probability. The median is also quite easy to have a look at. We're having a look for where our probability of it being less than a value is a half and greater than or equal to is more than a half, and we're going to talk about that in a little while when we get onto the example. Also, because this is a discrete distribution, we cannot have any other outcomes other than those listed, and therefore the probabilities of this value happening will be 0. So anything that isn't in our table of values will have a probability of 0. And also that means that all our probabilities that we have should add up to 1, which is a very good check if we have any missing values or probabilities that we're having to try and fill in. So here we have an example. So the table below gives the probability distribution for a discrete random variable x, the amount of money in pence a customer of an ice cream van spends on their ice cream. So we can see here the number of scoops of ice cream, 1, 2, 3 and 4, the amount of money that they cost, and also the probability of each person getting them. So 1 scoop costs 50p, and there is a chance of 0.4 of somebody coming up and ordering 1 scoop of ice cream. For 2 scoops of ice cream, that costs 90p, and that has a probability of 0.16 of happening, and so on. So we're trying to find the mean, the mode, the median, and the standard deviation for this data. So I'm going to go back to the data. I am going to do it here, but there is space on the next page in the notes booklet. So we're trying to find the mean, the mode, the median, and the standard deviation. So for the mean, as we said before, we're going to have the sum of the outcomes times the probability of those outcomes happening. So I'm just going to have a quick check to see if we're having a look at the mean price or the mean number of scoops. Here we're looking at the following measures of spread and average for this data. Doesn't say whether we're looking at the scoops or the amount of money spent, so we'll find it for both just in case. So when we're looking at the scoops, that means that we're going to have 1 times 0.4 plus 2 times 0.16 times in the outcome by the probability of the outcome plus 3 times 0.24 plus 4 times 0.2. So the mean number of scoops is 2.24 scoops. If we were looking at the mean cost, then that would be 50 pence times 0.4 plus 90 pence times 0.16 plus £1.30 times 0.24 plus £1.60 times 0.2. So the mean amount spent is £0.98 rounded to a sensible number, but I am going to write it up here as 0.976 as well, just so that I have the whole number that was written down in my calculator. For the mode, again, for the scoops, the mode amount of scoops, that's the one with the highest probability, so we're looking at this value here because this gave us the highest probability. So the mode is 1 scoop. For the cost, it's 50 pence. So most people spend 50 pence and they get 1 scoop for that. Now for the median, we can have a look at different values and we can try to find out where we have what we were talking about before. So if you have a look at the probability of x being less than 1, that gives us nothing. If you have a look at the probability of x being strictly less than 2, well, for it to be strictly less than 2, that gives us just the probability of it being 1, which is 0.4. Now that isn't quite far enough because we haven't got a half yet. So if we have a look at the probability of x being less than 3, that means that we could have 1 or 2, which gives us 0.56. So that means that the probability of our having less than 3 scoops is 0.56, which means our median is 2. Now an easier way to think about this is if we did a cumulative frequency of our probabilities. At the end of 1 scoop we have 0.4, at the end of 2 scoops we have 0.56, so somewhere inside our 2 scoops is our median because we've got over the probability of getting a half. Otherwise you can try looking at the different probabilities as we did here. For the standard deviation, remember we can't find that straight away, we have to start off by finding the variance. And for that we're going to have to find e of x squared. And then subtract e of x all squared, the mean squared. So for our e of x squared, remember that means that we're doing the sum of x squared times the probability of each one of those outcomes happening. So we're going to have 1 squared for the scoops first. So for scoops, we'll have 1 squared times 0.4 plus 2 squared times 0.16 plus 3 squared times 0.24 plus 4 squared times 0.2. So the E of x squared for our scoops is 6.4. And for our cost, that's going to be 0.5 squared times 0.4 plus 0.9 squared times 0.16 plus 1.3 £1.30 squared times 0.24 plus £1.60 squared times 0.2, and that gives us 1.1472, and I'm going to keep it as my whole number because I'm still doing some working with it. I can round it to 3 significant figures at the end. So when we're trying to find the variance, we're using our E of x squared, so for the scoops, using our E of x squared minus E of x, which remember is the mean, which is 2.24 squared. So that's 6.4 minus 2.24 squared, which gives us 1.3824 for our variance. Again, I'm going to keep the whole number for now because that's the variance and not the standard deviation. For the standard deviation, remember that this is for the number of scoops that we have. We are going to have to square root that value, so square root our answer, which gives us 1.18. And now I am going to round that to 3 significant figures. So notice how when I was still doing some working, I kept my numbers unrounded until I got to the end here. So for the standard deviation of the cost, for the variance, remember we have to start off with variance. We'll have our E of x squared, so our 1.1472, minus, just going to move this over a little bit, minus our E of x, and I'm going to use this unrounded value here because I'm still doing some working with it, so 0.976 squared. Just put a line here to separate these. So that's 1.1472 minus 0.976 squared, which gives us 0.194624, and again I'm writing that down unrounded to begin with. For the standard deviation, we want to square root that answer, which gives us 0.441 for our standard deviation for the cost. Now, next we're finding the probability that the next person to buy an ice cream will spend more than £1. So if we have a look back and we have a look at what we have here, the only ways that someone can spend more than £1 is to buy 3 scoops or 4 scoops. So that is taking into account 0.24 and 0.2. So for this question here, it's going to be 0.24 for our 3 scoops plus 0.2 for our 4 scoops, which gives us 0.44. Notice it says an ice cream, not some ice cream. So that's why we were only looking at ways that people could spend more than £1. Find the probability that the next person spends exactly £1. This time it doesn't specify how much ice cream they're buying to do this. So that means that the only way that somebody can spend exactly £1, well, we can't spend 90p and then make it up to £1 because they don't sell anything for 10p. And the £1.30 and £1.60 are both already more than £1. So the only way that somebody can spend £1 is by buying 2 ice creams for 1 scoop each. So we're wanting them to spend 50p and another 50p, which is 0.4 as our probability. So for this one, we have 0.4 and, so times 0.4 So 0.4 times 0.4, which gives us 0.16. I'm going to give you a second now to pause the video and give the Now You Try question a try before we go through it. Okay, so for the Now You Try question, we've got a news agent which sells phone cards valued at £1, £2, £4, £10 and £20. And they're regarded as a random variable x with the following distribution. And again, we are asked to find the mean, mode, median and standard deviation. So we're trying to find the mean, the mode, the median and the standard deviation. So to start off with the mean, we're going to have our sum of x, the probability of x equaling x, which means that we're doing 1 times 0.2 plus 2 times 0.4 plus 4 times 0.22 plus 10 times 0.11 plus 20 times 0.07. Just double checking I've typed all that incorrectly. So 1 times 0.2 plus 2 times 0.4 plus 4 times 0.22 plus 10 times 0.11 plus 20 times 0.07. Good, so that gives us a mean of 4.38. For the mode, we just have a look at our probabilities and see which one is the biggest. So that's this one here. So the mode, the most common amount that people buy is £2. The median, remember for an easy way of doing that, we can just add a cumulative frequency to the side. So by the end of the £1 ones, we're at 0.2. By the end of the £2 ones, we're at 0.6, which means that somewhere in those £2 ones, we have our median because we've got past a half. So our median is 2. For the standard deviation, remember that we have to start off with the variance, which means that we're doing the e of x squared minus e of x all squared. So for our e of x squared, remembering that we're doing the sum of x squared, probability of x equaling x for each one of these. So that's going to be 1 squared times 0.2 plus 2 squared times 0.4 plus 4 squared times 0.22 plus 10 squared times 0.11 plus 20 squared times 0.07, which gives us 44.32. So for the formula for our var of x, we're going to have 44.32 minus our e of x, which is this value here, our mean. Remember, the expected value is another word for the mean value. So 4.38 squared. So that's 44.32, our answer from the previous part, minus 4.38 squared, which gives us 25.1356. And I'm going to keep all that value for now because I haven't quite answered the question. It was asking for the standard deviation, and that's the variance. So we're going to have to square root our 25.1356 for the standard deviation. So square root our answer, which gives us 5.01 to 3 significant figures, and that also makes sense in context because we were talking about money, so that's pounds and pence. So then we're asked to find the probability that the next phone card sold will be less than £4. So if we have a look back at our probabilities, Less than £4 means that it's £1 or it's £2, which means we're adding 0.2 plus 0.4, so 0.2 plus 0.4, which gives us a probability of 0.6. So then we're given some extra information. We've got the news agencies wondering whether to discontinue selling £1 and £2 cards. If she did this, a proportion P of the customers who presently buy £1 and £2 cards would buy £4 cards. Other such customers may not buy any cards because they may decide, oh, you're not selling what I want, I'm going to go somewhere else. As a result, the value in pounds of sales would be a random variable y, which has the following probability distribution. So this is describing how they feel the sales are going to go. So here we can see that we've got a new value which is 0, which are the customers that are deciding not to buy anything. And on top of the 0.22, which was the probability of people buying £4 cards before, we have 0.6 times P. And we're trying to find the mean value for y in terms of P. So this time we can't use our calculator for it, we're going to have to do most of this by hand. So remember, for our mean, same as the expected value, we're going to have to do the sum of x times the probability that we get that value of x, which means that we have 0 times 0.6 times 1 minus p, plus 4 times 0.22 plus 0.6 p, plus 10 times 0.11 plus 20 times 0.07. So obviously the 0 times 0.6, lots of 1 minus p, that's going to end up giving us nothing because 0 times anything gives us 0. From this part here, we're going to have 4 times 0.22, which gives us 0.88. We're going to have 4 times 0.6p, so that gives us 2.4p. 4 times 0.6. Yes, that's our 2.4p. Plus 10 times 0.11, which gives us 1.1. Plus 20 times 0.07, which gives us 0.14. So that, when we put it all together, gives us 0.88 plus 1.1 plus 0.14, so 2.12 plus 2.4p. So a survey suggests that the value of P will be between 0.5 and 0.7. So we have an equation here for the expected amount of money that we're going to get from selling these phone cards now that we're not selling £1 and £2 cards. Using this information, advise the management on the likely effect of takings if she decides to discontinue selling £1 and £2 cards. Also point out one factor other than the receipts from phone cards which she could consider before making a decision. So in terms of the what would we advise her to do? Well, if we have a look at what happens with these two numbers and compare it with our mean from before, so remembering that our original mean was £4.38. So £4.38 was our original mean. So if P is 0.5, so if P is 0.5, so looking at the lower end, the pessimistic side of things, then we're going to have 2.12 times 2.4, plus 2.4 times 0.5 gives us £3.32. So that is less money than what we were earning before. That's what we were earning before. If the probability is 0.5, then we only earn this much. If the probability was 0.7 though, so the same equation as before, our 2.12 plus 2.4 times this time, 0.7, that gives us £3.80. So it doesn't matter whether it's on the optimistic or the pessimistic side of the scale, she's not earning as much as she did before anyway. So that means that I would advise that she continues to sell £1 and £2 cards as I've put she, but I'm not quite sure what the gender of the shopkeeper is, will earn more money. Now I haven't fully answered the question here. I've given some mathematical proof and I've written it in words, but it also says, also point out one factor other than the phone cards which she should make a decision about. So she should have a think about what else these people buys. So she should consider other purchases these customers make because, for instance, if these people who decide to go elsewhere, so these people that we're saying give us zero money, if we are saying, oh, we're not going to sell you the £1, £2 cards anymore, and they say, fine, I'll go elsewhere, if they usually spend a couple of pounds on chocolate bars or something like that, also at the register, then the shopkeeper is losing out on those as well. So that also needs to be taken into consideration when they're deciding what to do. That's it for now. Next time we're going to have a look at how to scale using the mean and the variance. Thank you very much.